Okay, since we have more people now, I think we're gonna start. So I'm gonna share my screen. So I'm not sure how many of you guys have been paying attention to the curriculum or if you even got it, but we were supposed to learn something else today, but I pushed it back, and then we're gonna catch up at the end of the class at the end of the course because I think with quadratics, there's still a lot more to learn that Stephen didn't cover that first day. There's a lot more material that's there, so I think we're going to continue learning about quadratics. And then there's also an update on the office hours. So I sent all of you guys an email with the link for office hours. Cloud Classroom and I were able to figure it out. So I think it's all in the email. There is one mistake though. I wrote 5 to 7 p.m. Pacific time. It should just be 5 to 6 p.m. And then for those of you in China, that's I believe 8 to 9 a.m. China time. So for those of you who want to do it, and it's Saturday, so we're going to have one tomorrow. And you can just come and ask questions about the lectures or the homeworks or any other doubts you have. So we're going to get started on this. So I'm going to warn you guys ahead of time. This lecture, a lot of the problems are very tricky and complicated. So I'm going to give you more time to do the problems. And then I want you to go over these problems later when I send out the email, since a lot of these concepts are pretty tough to grasp in one class. So we did talk about binomials and squares. So I'm going to give you guys 10 minutes to do this first problem. See if you can figure them out. Some of them are more challenging than others, but I'll give you 10 minutes or so, and then send your answers in the chat, and then I'll again call on someone to answer these questions. Okay, I'm going to give you guys just 2 more minutes to finish up these problems since I've only had 2 people respond with answers so far. And then after that, I'm going to call on someone to answer the questions. Okay, so for this problem, I think that's enough time. So would I think for this problem, I'm just gonna tell you the answers, and then for the next problems, I'll call on someone. So for this one, the answers are as follows. And for each of these problems, essentially all we've done here is we take this part, the constant, we add it to the other side, right? And then for A and C, after that, all we do is we square root them. So in this case, it would just be x squared equals 12. So we square root both sides. You get x equals plus or minus the square root of 12, which is plus or minus 2 root 3. For C, we do the same thing. It's -9. So when you square root it, you get positive 3i and negative 3i right here. It could also be written as plus or minus the square root of -9 if you don't want to convert to imaginary. And for the other two problems, it's a little more complicated. So when you add this 12, you get z plus 3 quantity squared equals 12. So you square root that, and then you subtract the 3 over to the other side, and that's how you end up with this -3 plus or minus 2 root 3. Because when you add this to this side and you square root it, you get your plus or minus, and then you get the -3 at the end. That's the same for this problem, but since it's -9, that's how you get plus or minus 3i, because the square root of a negative number is imaginary, which we learned last class. So then we're going to go on to the next problem. This one is a little more complicated as there's variables and stuff, but so you have this quadratic here with some constant. And essentially what this problem is saying is that this equation with whatever this constant is can be written as a square binomial. So x plus some constant times x plus that same constant again. So x plus a quantity squared. So it's essentially asking you what a and c must be. So this one might be a little difficult, but since it's only 2 parts, I'll give you guys 7 or 8 minutes. And then send your answers in so I can gauge how many students are done with the problem and we can continue on. Okay, so I've only gotten 2 responses again so far, so I'll give you 2 more minutes on this problem. Okay, so it's 7:23, so we're gonna end work time on this problem, and Sandy did send in the correct answer for me, which is A is 16 and C is 256. So Sandy, would you be able to explain how you got to those solutions?
Well, x plus a, well, the whole thing squared is basically x squared plus ax plus a squared, and the middle part, which is 32x, is kind of just 2ax, and which means 32 is 2a, and you just divide 2 on both sides, and a is 16. And then c, which is a squared, will be just 16 squared, which is 256.
Yep, that's correct. That's a perfect explanation. This is a very long-winded explanation with a lot of words, but I think Sandy did a much better job at explaining it. It was more concise. So essentially what she just said, just expand it out, set them equal to each other, cancel out the like terms, you end up with this. Then you just do some more algebra, and then you'll essentially get the two answers, 16 and 256. So here's another problem, which is kind of similar to the last one, except in this case, what you have to do is you have to find some c, which will make x plus a perfect square will equal this. So you have to find a and c, but the extra caveat is that this needs to be a perfect square. So try doing these 3 problems. So I guess this problem was very similar, I think almost exactly similar to that problem. So since you guys have already seen one of them, I'll give you 15 minutes to do all 3 and then send in your answers again. So far, I've only gotten 2 people responding to me with the answer, so I'm going to give you guys some more time, and I want you guys to send in your answers so I know how far along everyone is. Okay, so we have a lot more slides to get through, so I think we're just going to end this one here and then continue on. So here, so the answers to A and B are here. So one neat trick is that since the coefficient for the quadratic term is 1, to figure out C, all you have to do is divide it by 2 and square it, because that's how, when you square, that's how the algebra works out, since you're essentially squaring it and multiplying it by 2. So when you do this, you can figure out what your answer is for C immediately. And then once you have C, it's just a matter of algebra and factoring to get this. It's the same with B. If you use the same formula, you'll get your answer. And then it's the same thing with C. So that's how you do all 3 of these problems. It's a relatively simple trick. I know I didn't tell you that ahead of time. I wanted to see if you guys could figure it out. But also, if you just look at them and analyze the problems, you can figure out those things as well. So what you essentially did there was this idea called completing the square. So what you're doing is when you have an equation like this, even if you do bring the 2 over, you can't really factor it. It's really hard to factor. So what this essentially does is it takes this side, and then you're essentially trying to make this into a perfect square. So if you have x squared plus 4x, you have to think of a constant number you can add to this to make it a perfect square. So in this case, it'd be x plus 2 squared, because x plus 2 squared would be x squared plus 4x plus 4. So essentially what you're doing is you're making a complete square. And then since you added 4 to this side to get this answer, you add 4 to this side, which should make it 2. So this is a thing called completing the square. It's an alternative to just the normal factoring Stephen taught you in the very first class. So here's a problem specifically with completing the square, and I want you guys to try doing it with that method. I'll give you 6 or 7 minutes to try to do this problem. I've only gotten in 2 answers so far, so I'm gonna wait another 2 minutes. Okay, I think I'm gonna explain this problem now. So, so essentially we have this equation. So what we're trying to do is we're trying to make this side a square binomial. So you just have x plus some constant squared will get you this entire side, because then that makes it easier to find the solution. So in this case, we do the same thing as before. We take our linear term divided by 2 and square it, which equals 16. So when we do that, we get x squared plus 8x plus 16. However, we also need to remember, since we added 16 to this side, we need to do the same to the other side of the equation. When we do this, this factors down to x plus 4 squared equals 30. And then you square root the 30 and you get plus or minus square root 30. You subtract the 4 over and then you get your answer. This is very similar to the problems we did earlier. So again, here's more practice with those completing the squares. However, with these, you need to manipulate the equations around to get the correct format. So that's the additional challenge on these. Since you guys have done so many, I think you'll be faster. So I'll give you 10 minutes with these. So at 8 o'clock, I'm going to explain all of these to you. And and only do part A and part D, since a lot of these take a long time. Just do the first and last problem. Send your answers in the chat. You guys have 3 more minutes left on this problem. Send in your answers into the chat so I can check them for you. Okay, so I'm going to call time on these problems and then I'm going to explain them to you. So with the first one, you just take the -13 to the other side, make this a square binomial. All you have to do is add 1, you get this right here, then you square root it, you simplify that to plus or minus 2y root 3, and then you just subtract the 1 over, and then you get this answer. Here's the solution to D. It's very similar to the one I just talked about. So the trick with this problem is you need the x to not have any coefficients in front of it for this idea to work. So you just divide everything by 5 to make sure there's no coefficient. Do the same thing with this middle term again, divide it by 2. 3/5 divided by 2 is 3/10, then you square it. And then you have the 9/5 on this side, and then you just add the same thing over to this side. And then that's all you do, you work it out. And then you have this whole thing plus the 9/5 from earlier equals 9/100 over here. And then you just solve that out and then you get your answer for this problem as well. I know these problems are a little long, the solutions, and we're kind of a little low on time. So when I send this PowerPoint out, I recommend you go through these solutions again. So we talked about factoring. We talked about Stephen talked about factoring the very first class. Then I talked about special factoring with special cases. Then today we talked about completing the square. There's one more way to solve these equations, and that is the quadratic formula. This is a more of a last resort thing, and the one important thing you need to remember is that one side of the equation always has to be 0 for these to work. So essentially, this is just a straight up formula, which is negative b plus or minus square root of b squared minus 4ac over 2a. The a's stand for the linear terms, the coefficients in front of the linear terms. So for this one, a would just be 1. The b's stand for the linear term and the coefficient in front of it. So for this one, the b's would be negative 5. And the c stands for the constant, and in this case, it would just be 6. So what I want you guys to do is I want you to use a calculator. These are very hard to do by hand. Use a calculator, try to solve these. But when you solve them, don't write your answers in decimals. Write them with square roots and fractions, because that's how the answers will be. So I want you both to do these problems, and I'll give you another, say, 5 to 10 minutes on these two. I've only received one response so far, so I'm gonna wait 2 more minutes. And just again, I'm gonna remind you that you guys can use a calculator for these problems. Okay, I'm gonna call time on this problem. So for I don't know, I didn't put in the answers for these, but the answer to part D is 2 and 3, and the answer to part C is -3 plus or minus 171 I over 10. So if you just plug these numbers in, you'll be able to get them, and that's all there really is to these. Is just making sure you don't mess up the arithmetic. So here's again another problem with quadratic equations. I will give you, say, 8 minutes on this problem. They're the same as the last ones, except some of them have different like eyes and stuff in them. So this is just a little more difficult. Okay, I think we're gonna call this question right there. So, some of these answers are a little complicated. So for the first one, there's not much explaining to do. If you want, you can review these after class when I send the PowerPoints, but you just do all the math. You end up with r minus 8, r plus 12. So your answers are 8 and negative 12 because those will make this equation 0. Same thing with b. You just put them into the equation, and then since this is actually a square binomial, you only have one answer, and that answer is what is known as a double root, because every quadratic has two solutions, imaginary, real, and this one only has one. So that it's kind of like that solution counts twice. And then it's the same thing with C. You just solve the equation, do the math. This is your answer. It's more complicated. And again, the same thing with D. The only difference is the answers here are imaginary. So one of the answers would be I, and the other one would be negative. It'd be negative. God, it would be negative 1/7 I believe. So that's it for this problem. And then no, this would be just negative 7I. So that's all that would be for this problem. I believe we have 2 questions left. So we do have a challenge problem. So we're just gonna skip this one for now. You can do this later on your own time. And then this is a challenge problem. It's not too hard, but send for any of you that can figure out the answer to this problem, send your answer in the chat. And then I'm gonna call on someone to answer and explain this problem. This is the last problem for tonight. Okay, I think that's enough time for this problem. We're gonna end a few minutes early today, but that's fine. So for this problem, all you have to do is you cross multiply the terms over so you can cancel out all the denominators. Let me move this. So you multiply both sides by this part, and then when you do that, you end up with this equation here. You're just expanding out the terms, combining like terms, putting everything over to one side to make it equal 0, and then use the quadratic equation, work it through, and you get your answer at the bottom here. So that's all this problem was. It wasn't really difficult. I think the main concept was realizing you had to do the cross multiplication for this. And then, so today, overall, we went over 3 different things. We talked about factoring, which again, Stephen talked about during the first class, and then I talked about during the second class. And then that's one way to factor these binomials. Another way is completing the square, which I talked about earlier, where you get a square binomial and then you add something to both sides and then you can solve it easily. And then we talked about the quadratic formula at the end, which is just plug and chug, figure out A, B, C, put those into the equation, you get your answer. So these are the 3 different ways, the main ways that you can do it. Another way is to graph it on a graphing calculator and get your answers, but you need to have a graphing calculator for that, and that takes more time, which we'll probably talk about later in this course. So, and then updates, I talked about this at the beginning of class, but I don't know how many of you were listening. So a lot of you have asked for office hours, like at least 6 or 7 of you have asked for them. So Cloud Classroom and I worked something out. So they will be Saturdays. So the first one will be tomorrow, and they're from 7 to 8 p.m. Central Time, 5 to 6 p.m. Pacific Time, and then 8 to 9 a.m. China Time. So if you have any questions, please try to make it at any time. You don't have to be there for the whole hour. You can pop in, ask your questions, and leave about the lecture, about homework, about anything related to this class. This is the Zoom link. This is the meeting ID and passcode. You don't need to take a picture of this because I sent you guys an email earlier today, which you should have received with this information. And I'm going to send a post-class email with this PowerPoint so you have the links again. So if you have any questions, I highly recommend you come to these instead of just keeping those doubts with yourself, because it'll be more difficult as we add on to those concepts throughout the course. And that's it for today. If there's any questions regarding the office hours, you can ask them, or you can just head on out.
Uh, Wait, are my answers right though? For the challenge?
No, I don't think your answers were correct. I think you did some mistakes in the cross multiplying. So I'm going to send the solution out again, and you can check it with your work to see where it went wrong. And if you still don't understand it, just ask me tomorrow during the office hours. Okay, I think that's it. Okay, then we're done for today, Stephen.